Hello. Today we want to talk about evaluating the model performance. We have studied several models. Now we want to find whether a model is performing well or not. And in this context, we'll be talking about the confusion matrix. So, some concepts when we are talking about evaluating the classifier models, we want to measure accuracy. We talk about train set, validation set. We want high accuracy. Are there other evaluation parameters? So the first thing to begin with is confusion matrix, a very important concept. So the terms before we proceed on to define the parameters like accuracy, the first is true positives. So true positives are the positive tuples that were labeled as positive. That means correctly identified positive tuples. So if we are trying to identify a disease, then a positive tuples means the data or the tuple we are trying to identify has the disease. So positive tuple labeled as positive. Then we have the true negative. True negative is the negative tupled correctly labeled as negative. True, negative, true, positive. Then we have the false positive. That means falsely identified as positive but actually negative. That is false positive, falsely identified as positive. And finally, the false negative, falsely identified as negative. That means it was actually positive. Okay, so we are trying to classify between positive and negative. We can extend it to other many classes also. So positive is one class, negative is the second class. Right now, to make it simple, we are talking in terms of only two classes. So positive, negative. True positive is it was positive and identified as positive. True negative is it is negative and identified as negative. And false positive, it was negative but identified as positive, and similarly false negatives. We'll go through an example next. Okay. So finding the confusion matrix given a test set. See, first thing, when we are evaluating model performance, it is on the test set or the set which was not used during training. Okay, that has to be very clear. Evaluating model performance is always on an data, the data set which was not given to the model during training. So let us go through our example here. We have in all 8 data points and only 2 classes. Blue cross is the positive, so we have 4 P. We have marked them as P in black alphabet. And orange cross is the negative. Again, we have marked them as N. So orange crosses are negative. So we have 4 positives and 4 negatives. The predicted class, we are denoting the positive as a green plus sign and the negative as a red minus sign. Okay, this is the scenario. Now, we want to make the confusion matrix for this. See, first let us observe this. This particular, this data. What is it? It is positive. We have written P. It is a blue cross. It is positive. But what is the predicted class? It is negative. Okay. So for this data point, it holds that it is actually positive identified as negative. What about this? It is positive identified also as positive. So this will be a true positive. Similarly, this one is positive identified as positive. So true positive. What about this one? It is negative and identified as negative. So it will be true negative. So now we know how to identify the data as per the definitions we gave earlier. This is negative identified as positive. So this is a false positive. Okay, so now we write our confusion matrix, predicted class, actual class. Let us see how we get this P. So this value of 2 comes from this data point and this data point, right? So this is the true positives. Okay, true positive. 2 data points fall into this, which were positive, actual positive, and identified as positive. Okay, now what about this? Actual P identified as N, actual P here and here. So these two. So these are the false negatives. Okay, falsely identified as negative. Now we come to this. This is what actual N identified as P or predicted as P. So it is this one, this data point, and we have another one here. And see, the count is 3, and that is what false positive is 3. And finally, we have only one data, this one, which was negative and identified as negative, contributing to our true negative. So you can see that for 2-class data set, the confusion matrix is having its components as the 4 terms TP, FN, FP, and TN. Okay, so I hope this is clear. Now we go on to the definition of parameters. So the evaluation parameters, our most often heard word of accuracy. Accuracy is what? All the correct predictions, which is TPTN. Okay, it was positive, identified as positive. It was negative, identified as negative. So TPTN added, divided by the whole of the data set. So this is accuracy. Precision, it gives the ratio of true positives among positive predictions. So true positive we know TP, and predictions is what? The true positives are also positive predictions. The false positives are also positive predictions, but they are false. So this is how we compute precision. Then we come to recall, also known as true positive rate, gives the ratio of true positives among the total positives. So what is the total positive? It is the true positive plus the false negatives, because false negatives are what? It is actually positive identified as negative. Okay, so this is recall, and F1 score is the harmonic mean of precision and recall. So we simply take the formula for harmonic mean, and we also write it simply as 2TP by 2TP plus Fn plus Fp. Now we solve an example. We now do the computations for the evaluation parameters. Given the example which we had seen earlier of 8 data points. So accuracy is what? We see the formula here for references. TP plus TN is the sum of the primary diagonal elements 2 plus 1 divided by the entire size, which is 8. So 3 by 8. Precision is what? Ratio of true positives among all positive predictions. So positive predictions is given by this column 2 and 3. So TP by the total predictions. So 2 by 5. Okay. Recall is true positives by the total positives. So total positives is what? This column, actual. So this actual class P. So 2 plus 2. So recall is 2 by 4. Finally, F1 score is taken as this computation. Twice of TP by 2TP. By this, we get 4 by 9. So we've seen how we can define confusion matrix in terms of the true positives, true negatives, false positives, and false negatives. And on these terms, we also can compute our evaluation parameters such as accuracy, precision, recall, and F1 score. There are more parameters which we would like to see later on. So thank you. Thanks for watching.